welcome to your OPS 245 Week 2 lecture video, where we're going to look at some Python scripting, and all of this is going to tell you how to do the Python in that last investigation in Lab 1. And not just like tell you how to do it, like I'm gonna go through it with you, you're going to learn some stuff, and it's going to be not so bad. I'm going to warn you in advance, I'm not going to stick with the slides the whole way through. At some point, I'm just kind of going to go off the rails and start demonstrating stuff. And just as a reminder for the Python portion, which I'll bring this up when we get there again, we're going to be doing things a little bit differently than what's on the wiki. So you can pretty much just ignore what's on the wiki, in all honesty. And there's a PDF document in the Week 2 materials in Blackboard, and that's what we're going to be following. Because, well, it's better. Of course I'm going to say that I made it, but, like, it's better. I think it's better. A lot better. So Python. We're going to learn a whole bunch of things about it. Like, how to run simple scripts, why you want to do this, and well, what it is. Because that's an important thing, isn't it? So commonly, after you set up a new system, what you tend to do is you need to record and verify a bunch of information about the system. Things like what software is installed, what hardware is it running on, how is it connected to the network, running processes, stuff like that. And you're verifying this for a couple different reasons, right? To make sure that everything's configured the way it should be and you didn't miss anything or misconfigure anything. But also for documentation purposes. Network admins are really horrible about documenting what they do. And we could be better. And not all of them are horrible, right? But like historically, they've been pretty bad about this. So when you spin up some new stuff that's going to be in a production environment, you want to make sure it's well documented. So whoever comes along next to do some more development on that area of the network, it could even be you in like 6 months, actually knows what's going on by reading the documentation and can figure it out and just jump right in. Because again, it could be you in 6 months doing this and a lot of stuff has happened and you don't remember anything that you did 6 months ago, right? So you might be wondering why you did something. Also, having information about all this makes it a lot easier to expand the network when you're adding new hardware, or when you're diagnosing issues, or when you've got security concerns, right? You read about a big security concern, a zero-day vulnerability that gets leaked, and you go, oh shit, are we affected by that? And you look through your documentation quick and go, no, we're good, or oh yeah, we should patch that right away, right? Like, but you want to be able to find that information right away. So there's a whole bunch of useful commands we can use in Linux. I know you learned a whole bunch of commands in ULI, and some of these may be a bit of a review, but some of these are definitely new. You can use things like uname, with the -R and V option to get the kernel version, which could be useful. Hostname will give you the current host name, which again could be pretty useful if you're remote accessing into a bunch of different servers, right? You want to usually verify that you're on the correct server before you make some huge configuration changes and don't accidentally install a web server and configure it where it's not supposed to be or something like that, right? Just as an example. ps-ef will give you all the processes running on the system. rpm-q lists all of the packages on the system, and you commonly combine that with -a, which will show all, or -l, which will show just the files. Or you could pipe it to a word count -l to get a count of the number of lines, which would tell you how many packages there are. Pretty handy thing. And you're going to do all of these in the lab. So like, I'm not going to spoil the surprise, but now you should kind of have an idea about what they do, right? Now when it comes to gathering information about the network, you're going to want to use things like IP address show. That will display the current address, the current IP address. An IP route show will display the routing table for you. And NS lookup works just the way in Windows, right? We'll give you take you an interactive prompt where you can start querying the DNS server for domain names. Works just the way it does in Windows. When it comes to IP address show and IP route show, you might see some older commands floating around somewhere on the internet. ifconfig and route. Avoid those. Use these ones. These commands are newer. Those older commands are deprecated. The packages haven't been updated in like 20 years or something crazy. So they're probably going to just stop working someday, and we should use the new ones. Now, you might think to yourself, well, if we're going to have to do this every time we install a system, it's a lot of information and a lot of time to manually do that, right? Well, I think I've said it once already this semester, but I'm going to say it repeatedly throughout the semester. You could automate this, right? This is what I say every semester more than once. A good system administrator is a lazy one, right? Good sysadmin is a lazy one. We can automate repetitive tasks. If this is something that you want to do more than once, write a script, and then it's just there for the next time you need to do it. And you can even have that script send the output directly into a file, which is great. It really is. So we're going to learn how to do that. That's entirely what this is about, is you're going to learn to write a Python script to automate this process. Of course, you already did some of it manually, and that's okay. We wanted to show you the manual way before we show you the cool automation. Now, a lot of the commands that we're going to run, and some others that we're going to need in this course, you need root access to be able to use. And it's not a great idea to log into root if you even know the password, which in a shared admin account or a shared admin environment, in a production environment, in a real work environment, you probably don't know the root password, but you will have been configured access and given access with sudo, which we're going to use. Sudo works just like run as administrator in Windows. So you just stick that in front of any command that you want to use or execute with elevated privileges. It'll prompt you for your password, and you can technically configure it to not do that, but I don't recommend that until you get more comfortable. And it just does it. It's great. So we're going to learn all about sudo in this week's lab as well. Lots of things in this week's lab. And scripting, well, I know you only had 2 weeks of scripting in ULI 101, and I asked you last week how many people were scared about scripting, right? And a few hands went up. Don't be. You only had 2 weeks of bash, that's okay. You're going to learn more. The great thing about scripting is the more you do it, the better you get at it. And no matter how experienced you are, you're going to make mistakes. I make mistakes all the time, and I'm very experienced with scripting. So there's lots of ways to get experience with this, and kind of figuring things out as you go is a super important skill. Nobody ever sits down and writes a script once and it's flawless and doesn't make a typo and it works perfectly exactly the way they want. Well, maybe they do. I've never had that experience, like ever. Now bash scripting we used in ULI 101 that couple weeks, right? The bash shell is what's running in Linux. It's native on the system. It's already there. But a big difference here, Python might not already be on your system. And if it is, it might be Python version 2, which is obsolete. I say obsolete, it's still around. Especially in CentOS, because, well, it's old. So you're going to need to install Python 3, and that's actually one of the first things we do, is sudo yum install Python 3. And if you want to be lazy, sudo yum-y install Python 3, and it's just straight up there. So Python 2 is deprecated. It's no longer supported. It's deprecated as of January 1st, 2020. So like 3.5 years ago. It's a good time. It's still kicking around. CentOS 7 It's an old operating system. It's been around for 10 years. It still uses Python 2.7.5 because that's what the version of Yum that's in CentOS 7 uses. You can upgrade. We're not doing that in this course. That's just totally not what we're doing. But we're going to run every script when we write it explicitly by calling Python 3. And let's actually just ditch these slides and go to our exercises, shall we? Let's go to our exercises. I think it's a better time. That's not our exercises. Where did I stick them? Bear with me a second. Here we go. So as promised, in your documents folder in week 2, content, no documents folder anymore. Content, week 2. Week 2 scripting exercises. That's what we're going to be working through. I modified this from the pre-existing stuff quite heavily. And I meant to edit some more, and I just didn't. So you don't have to do everything in here, but we're going to play around with a bunch of the stuff, and I'll tell you, well, as I go through it with you, what you're going to want to do. So scripting, yeah, I mentioned this, right? This is going to come up time and time again. It's an essential skill for sysadmins. Even in Windows, you want to learn PowerShell to make your life a lot easier. A good sysadmin is a lazy one, right? They write scripts to automate repetitive tasks. Things like creating users, backing up files or systems. Why manually do that when you can write a script to do it? You got 500 users to create, maybe like here at the college, right? Every semester, every 4 months, you got to do that. Do you think somebody's sitting at a computer madly typing away with everything? No. They run a script. They automate it because they're lazy. Now shell scripts are really, they're nothing more than a sequence of commands. They're the commands that you would execute from the command line, just in a script, in a special script. And in fact, some of the earliest scripts that you write, some of the earliest scripts that I learned to write, will be that, right? They'll be the exact same commands you would have issued from the command line, in the same sequence, just in a script with the appropriate line at the top. The shebang line, which we learned about in ULI 101, right? The shebang line is the path to the interpreter. It has to be the first line in your script. And if you remember from ULI, the bash shebang line is pound exclamation mark bin bash. I don't know why it highlights funny like that when I do that. That's weird. In Python 3, it's a bit different. It's pound or bang exclamation mark. I always say pound exclamation mark, but it's bang sh. That's shebang. Or maybe it's the other way around. Yeah, sh. And then bang. That's what it is. I knew there was a where they got that. So pound exclamation mark user bin env Python 3. So that has to be the first line of your script. If it isn't, and you try to run it, it's not going to execute properly. Bash is going to try to execute it. Bad things are going to happen. It's just going to be a fun time. Now when you're running them, we're going to put everything in a bin directory in our home directory, and that's part of our path variable. But normally when you run a script, you run it with / the name of the script, right? That's how you ran bash scripts in ULI. That's how we're going to run Python scripts here. And if the script is in one of the directories in your path global variable, which you can look at by just echoing $path, all in caps, then you can call it without the / from anywhere in the file system. So that's why we're going to be putting everything in our bin directory. And it should work. Another thing that we looked at from ULI 101 that applies here, permissions. When you go to execute a script, you have to make sure it has the execute permission, right? So we use the chmod command, chmod +x, right, to add execute permission script.bash. Now what's the difference between these two commands? Just as a quick refresher. This is easier when we're in class. Chmod +x on its own, and then script.bash adds the execute permission for user, group, and other, everybody, to that script. Now, our servers, we're the only ones accessing them, right? You're the only one accessing your server. I'm the only one accessing my server, so on and so forth. But in a production environment on a real server, that might not be the case, right? So you want to be careful who you're giving that execute permission to. You might want to be a little more specific. chmod u plus x might make a lot more sense. So just keep that in mind, right? Security, a little bit of security. We can embed a little bit of security in our configuration and in the way we do things. We can do things in a little bit slightly more secure manner. So both of those will work, right? But one of them a little less secure. So I'd go with the second. Global variables or environment variables, right? So $PWD, it's an environment variable. Anything with a dollar sign and then all caps in front of it, that's an environment variable in Bash. It's a handy thing. And exit codes, a useful thing too. They're stored in a special variable in Bash called $?, and that will tell you the exit status of the last command, and we're going to use that in our script. I think this week, maybe next week. We're going to use that in one of our scripts. The important thing here is that Linux uses an exit code of 0 to represent success, and any non-zero code represents failure. We can use that in our Python scripts by assigning exit codes, which you'll see in a little bit, when a script fails, and pass that to the operating system. So Bash will represent that appropriately to the user. So I'm going to relate a lot of this to what we've learned in Bash so far. We're going to learn about variables now. Then we're going to actually, I promise, we're going to get to some writing shortly. In Bash, if you remember, you can create a variable anytime. And you don't have to assign data types to it, as you do in other languages. Python works similar. All Bash variables are character strings by default, but they act as other data types based on the context of you use them, or as you use them, right? So for example, if you perform a math operation on two variables, Bash treats them as numbers. And to assign or create a variable in Bash and assign a value to it, we just say that the name that we want to call it, this should be a human readable, sensible variable name, and equal sign, and its value, which could be optionally in double quotes, or not in this case, right? There should be no spaces on either side of this. Your variable names have to be alphanumeric, and they can't begin with a number. And if you want to get the content out of this in Bash, you just use the variable name with a $sign in front of it. And that $sign means the value of whatever follows. So for example, we use the echo command, echo $number. If we've set number to equal 1, we'll print out 1, right? Now Python is a bit different, but also a bit similar. Python variables can be used exactly the same way we use them in Bash, where it'll figure out the type of variable it is based on the context. So you don't have to create a type or assign a type when you create it. But Python also allows you to do this if you wish. You can assign or specify the data type that variable should contain when you create it. It's called casting, and don't worry about it too much. We might look at it later in this course. We didn't end up getting that far last semester just because nothing took us there. But yeah, if there's like an interest time thing or whatever, maybe we'll take a look at it. Don't worry about it too much. You can just straight up use Python variables the same way you use Bash variables and have things figure out what they are in context. That's going to be totally fine. So we're just going to do that. Now in our previous thing we looked at assigning the value of 1 to number and then printing it out in bash, right? Well, here's how you would do it in Python. Number, note the spaces here, and then it equals 1. So there's a space on either side, and Python requires that. And in fact, one of the things that drives people crazy about Python is the spacing. Because if your code isn't properly spaced and indented, your code won't run. There's going to be syntax errors. Python looks really clean and neat, but part of the reason it gets that, or part of the way it gets that, I should say, is that it uses indentation to know where things open and close, where they begin and end. So if your indentation's off, you're going to get syntax errors, and that's a big deal. Now, unlike bash, to refer to the value stored in a variable, you don't need to put a $sign in front of it. You just refer to the variable by name. So this example here will print out the value of the variable number, which we assigned above to 1, using the built-in print function. So print number with round brackets around it will do that. Really simple stuff, I know. We're gonna tie it all together in a more complex thing, but like you gotta walk before you run and crawl before you walk, right? User input. So you learned in ULI, you can prompt users for input and store them store it in variables using the read command in bash. So there's two ways you can do this. You can echo please enter your name and then read name, right? Use 2 lines here, or you can do it both in one, read-p, the prompt, and then name. Either of these does the same thing and are correct. You can use whatever you want. Python, it's a bit different. We use the input function in Python, and it works very similarly to read-p. You can assign it to a variable, so name in this case, equals input, please enter your name. So this is the prompt that's going to be displayed on the screen. Always remember to throw an extra space in here because it's a handy thing. So that gets displayed on the screen. The user types their name and it gets stored in name. Really, really simple, useful stuff. In bash, if you remember, single quote suppress shell expansion, so variables and commands don't get expanded to their contents. Double quotes allow that. In Python, there's no difference. They both allow variable expansion. You can use whichever one you prefer. So if you like single, use single. If you like double, use double. Just be consistent. And you have to match your opening and closing quotes, or otherwise you're going to get issues. I'm going to let you read through all this stuff, but we can pipe output to and from a file. You should know how that works, or from one command to another. You should know how that works and how piping works. We learned about that in ULI 101. And you should learn, or you should know these basic commands here. So cat, grep, cut, they're handy. Now before we get into to Python stuff, just quick, we're going to actually do some stuff in a minute. In bash, we use conditional statements or if statements to add logic to our scripts, right? To check to see if a condition is met and then change the behavior of the script based on that. And here's a sample here, right? So if grade is greater than or equal to 50, echo congratulations you passed, else, well, it's less than 50, so they failed. So echo, I'm sorry, you failed. We're not going to be a jerk and say, haha, you failed. I mean, we could have, but we didn't. Python has these as well. We're not going to cover them this week. We are going to cover them in a future lecture. Now for the fun part. And we're doing this a slightly different way. Well, it's actually kind of a brand new way this semester. It's going to be awesome. I distributed templates for code that we then wrote last semester. And we did something awesome. We just stuck them all in a GitHub repo, and you're just going to clone it. So you have everything. Isn't that great? So you're going to want to grab all this stuff. I'm going to actually switch over to my host and stick this on one of my other monitors, and we'll see how this works. And I was actually, well, there's no time on the screen. I just paused for a minute and checked something out, and I'm gonna revise this command ever so slightly in my demonstration to show you a handy way to do this. So we're only going to do this once. It's going to give us a whole bunch of things, including these two samples. Now in my C7 host, and you're probably looking at this right now thinking, that's not CentOS 7. That's not how my interface works or looks. It is CentOS 7. I just I installed the Cinnamon interface because I happen to really like it. It looks a lot cleaner and neater, and seems to be a bit more responsive in a VM too. So I did that. So this command is directly in that exercise at the top of the files, the git clone, but I'm going to modify it slightly. Git, clone, the repo we want to clone. And here's the cool thing that I figured out. I don't want that to go in a Python directory. I want that to go into the bin directory, because that's where we're going to be creating stuff. So I can just specify bin here. And look at that. I should have done an ls before. Everything's in there. Isn't that great? So let's go see what we just got. We just got all the templates we're going to need for the whole semester in one go. So I'm going to change to bin. I'm in the bin directory in my home directory. Everything's good to go. And the next part of the PDF says this is a suggested order for these exercises. You should do them in the first little bit. That was, I cleaned up the ugly output there and I made it better, but I didn't make it great. So the first ones we're going to do are hello.bash, which I think is already here. Cat hello.bash. Yep, and cat hello.py. So the two different scripts. Let's just open them up in Vi, shall we? Take a look at them. I've already written all the code for you. It's all done. Actually wrote it back in January. So there we go. Hello bash. So this is how a properly documented script should look, right? Author, I usually put a semicolon in the email address in here. Date, purpose, and sample usage. Just because it's a good practice. So this is going to print hello, list the contents of the root directory, and then print goodbye. And we're going to call it with hello.bash. So here we go. We have a comment, print hello on the screen. We're going to do that with the echo command. So echo hello, should see that, and then follow that with ls/, and then echo goodbye. And oh, I missed something here. It's a good thing I looked at this. I wonder if this is going to run, but there should be a quote there, closing double quote. Let's see if it runs without it. So we need to give it execute permission, right? chmod u plus x. Hello.bash. Let's try executing it. Yeah, no, that fails, right? So let's fix it. That was unintentional. I am going to go fix that immediately after I finish recording this video. So you don't get that. Yours will be fixed. Hopefully, as long as I remember. Oh, my VM's a bit slow today. So let's clear my screen, run it again. Don't know why my VM's a bit slow today. It's weird. Not much going on here. So there we go. Did exactly what we wanted it to. Now let's check out the Python. Hello.py. So exact same thing. Shebang line's different, right? It was bin bash in the other one. It's user bin env python. We got my author, the date, the purpose, the usage, like pretty much the same. And note comments work the same. Now here's where things get a bit differently, or work a bit differently. We're going to first import the operating system module, import OS. We're going to print hello on the screen by using the built-in print function, and we're going to get a directory listing of the root directory, and then print goodbye. Same exact thing. So if I make that executable, and run it. I should have cleared my screen first. See, it did the exact same thing. Now here's something interesting. You may not know this command, but I'm going to show it to you. I'm going to clear it again, and I'm going to run them both again. But this time, I'm going to run them with the time command. What the time command will do is it'll show us how long it actually took to run. So we see the real sys user time that took 3.03 seconds to run. Now let's try it with the Python one. That's a significant jump, isn't it? For some reason, Python scripts, probably because they have to pass things to the operating system and stuff, and that takes a bit of time, right? Bash, we're scripting in the system's native language. They operate a bit differently. Just because. Or they operate a bit differently. They take a bit longer. Python scripts tend to take a bit longer than Bash scripts. So, those are our examples. And I think I said ignore the stuff, the investigation for. We're going to actually do it. And I'm going to show you something handy. If we do an ls here. Clear my screen and do an ls. We're going to actually just do it right now. This will probably take us 20 minutes. But again, like it would have been longer. So we're going to check to see if Python 3 is already here. We're going to install it. If it's not, it should already be installed in my system because I'm using the install from last semester. But then you're going to create this myreport.py, and oh, what's that? That we are going to do together. It's going to be great. So which Python 3? And we see it's already on the system. And if it's not installed, you can install it with sudo yum-y install Python 3. And I'm not going to let that finish because, well, it doesn't need to. It just doesn't need to because it's already there. And then I'm going to open that myreport.py. So here we go. Here's this handy template that I gave you. And all of the code for this is on the wiki. So we're going to use Vi to edit this, and we're going to do some cool stuff here. So I to hit insert or enter insert mode, and if you just hit insert, it works on my keyboard anyway. I can do this. So let's replace that. And the date. It is May 14th, 2023, not 2024. I'm not operating in the future. And I'm going to follow along with what's on the wiki and investigation 4, and we're going to fill this in. It's going to be great. So we're going to print out a heading to display on the screen first. It's going to be a system report. So we looked at how to do that. We used the print built-in function in the samples that I just kind of ran through. So print system report, and I'm going to throw a \n in there, which will print out a new line just because it's a handy thing. It makes it look a bit cleaner, I think. And feel free to use those liberally in your system calls to print out stuff if you think it makes it look cleaner. Because that's a good thing, right? Next, we're going to import the operating system module. So that's import OS. And that was in our thing. We're going to print out a new heading. So print current date. And notice I'm using different quotes than what's on the wiki. That's okay. And here's where we're going to do something fun. We're going to call the date command using the OS module. So we can use os.system. It's a built-in function in the OS module, and that's why we imported the operating system module. And we're going to pass it a command to run in bash and receive the output. To do that, we need to stick that in here. Whoops. I want to take insert off. There we go. Stick that in double quotes here. And this is going to be the date command, just like you would run it in bash. So we're going to specify the output with the date command, which you may or may not remember from ULI 101. And if you're not sure what these does, what all of these options do, well, you can wait to see what the output is. Or you could look at the man page. %i $%m space %p round bracket. And I need I need some single quotes there that actually matter. And let's give that a go and see if it works. chmod u plus x myreport.py, and let's call it or run it. Look at that! It executed. We got our system report, current date, and the date. Isn't that awesome? Now, based on all of those, we're going to add some print options. I'm going to do this with you, but you should be able to figure it out really at this point, because it's not terribly complicated. We're going to add some headings and run the commands. And you might be wondering, well, where are the commands? Whoops, I didn't want to make it executable again. I wanted to open it. The commands are in the last investigation you did. You actually ran all of these. So we're just going to straight up use those commands with wrappers, or with that os.system wrapper. There we go. Right? Let's go into insert mode. Well, did I only give you that much? I only gave you that much. It's okay. We can make this work. Now it says there should be 45 lines here. Whatever. So we're going to call the hostname command using the OS module, so os.system hostname. I think I'm going to be upgrading this or updating this template once I'm done this. Call print the kernel version. I think I said headings, right? So print a heading for hostname. Hostname. There we go. Need to print a heading there. Kernel version, and then we just steal that from our uname. Yep, -rv os.system. Told you I type pretty fast. It helps when I actually print a heading for the running processes. It's nice when I don't make mistakes when I print. processes. There we go. That's going to be our heading. Print the running processes. Running processes. There we go. So os.system. Oops, gotta scroll back up and swipe that. It's PS AUX. Print a heading for the IP address. I like that better. It's probably going to print IP addresses. os.system IP address show. Let's run it. Let's hope it works. Ooh, there it all is. So we might want to clean some of those up with some new lines, right? We can totally do that. This is where editing is a good idea. So I'm going to stick a new line in front of each of those. \n, whoops. You can just stick it right there. Makes it a lot easier. And then we'll get a new line. Look at that. Look at that. Isn't that great? Oh, I got a lot of processes running. So that's that. That's it for that investigation. I will have updated that template, so when you get here, it's just done. You should be able to finish up Lab 1 this week, and if you haven't finished your VM installs, don't panic. We're going to work on that this week in class. Don't forget, next week you will have Quiz 1, so not this coming week, but the following week, and that's going to be based on Lab 1. So, take care, be safe, thank you for watching, have a great week, we'll see you next week, bye for now.